Jai Hind everyone, my name is Shan Singh and I am second year B.Tech computer science student. This video is a we can say chain of a three-part video in which we have been covering the assignment of a computer organization and architecture subject. This is the first part, and in this we will be discussing about the control unit design. The topics of this videos are hardwired control design, microprogrammed control unit, as well as micro instruction design. Now, before discussing all these topics individually, let us first understand what is a control unit. Control unit. Now, control unit, this is a part of the central processing unit. Now, we all are aware about the central processing unit, often considered as the brain of the smart devices like computer. So now control unit is part of this central processing unit. Now it follows some of the functions. Let me list down those functions. The functions that are performed by the control unit includes first of all fetching information from the memory, then decoding those instructions to get some we can say so that computer can understand what does information mean. So decoding those instructions, then generating control signals, as well as to direct the other components of the computer to what to do. Now other components may include the arithmetic logic unit, the memory, register, as well as the input and output devices. So let me list down. Direct other components like the arithmetic logic unit called ALU, the register, memory, and input output devices. So what do we understand from it is that control unit part is the brain of our CPU. So this is what performs the major functions of the CPU. We will delve into deeper. So control unit is the brain of the CPU. After studying about the control units, let's now study about its type. So we can majorly divide the control unit into two types. First being hardwired control unit, and the other being microprogrammed control unit. So now let us understand both of these control unit designs in deep. Now our topic is hardwired control unit. So in a hardwired control unit, what makes it special is that the control signals are generated using fixed combinational logic circuits, for example gates, decoders, flip-flops, etc. So let me just jot it down. Control signals are generated through fixed combinational logical circuits. And what can they be? For example, logic gates or decoders, encoders, flip-flops, etc. Now one major thing is that there is no control memory in a hardwired control unit. Now, there's one very famous thing about hardwired control unit, which is that it is quite fast. It is very fast. Now, why is it so fast? So, in a hardwired control unit, everything is fixed within the hardware. So, it is not required for it to fetch information from the control memory. Now, this is the reason why it is very fast. So, we can say that since there is no need to fetch instruction from control memory, therefore it is very fast. Now let us understand the working of the hardwired control unit through a block diagram. So let me pause the video till I make the diagram. Right. So this is the block diagram for a hardwired control unit. Let us understand the parts of it. First of all, we have a instruction register. This is used to store the instructions which are fetched. So they are fetched and stored here. Next, we have an instruction decoder. As the name suggests, the function of it is to decode the instructions. And then we have inputs, which are inputs from buses and from flags. Here we have a clock. The clock is used to generate the timing signals. And then control unit, you can say, appropriately fetches the instruction and runs the appropriate job, and then gives us the control signals, which are then sent to register buses or the arithmetic logic unit. Now let us understand these functions step by step. First of all, let me list down all these parts which are used within the hardwired control unit. First was an IR, instruction register, then an ID, instruction decoder. After that, we have used inputs from system buses as well as flags. These are used as inputs. Even these are inputs, but these are inputs from buses as well as flags. Next, we have a clock. So all these things make the hardwired control unit. All these things actually basically are the inputs which are given to the hardwired control unit. Now let me just write down the step-by-step function. So first of all, what happens is that the instruction is fetched and stored within the instruction register. So the instruction is fetched and stored within the instruction register. Second, the decoder is used to decode the instruction. So the instruction decoder is used to decode the instruction. Then we have the counter, which is used to generate the timing signals, and then appropriately the control unit will generate the output signals. So a sequence counter that we use to generate timing signals. So now we have these inputs and we have this timing signals. So based on these inputs as well as the timing signals, based on the inputs as well as timing signals, the control logic will generate control signals. Now these control signals, these will be sent, let me first write it, will generate control signals. So whatever these signals will be generated, they will be sent appropriately to the arithmetic logic unit or to the register or to the memory or finally to the input output device. So the last step with the working is that these control signals are sent to first the arithmetic logic unit registers to the memory and to the input output devices. Now, what happens when the execution is completed? So, after the execution, it can be guessed easily as well. End signal is generated, and the sequence counter is now reset. Reset means it goes back to its initial position, which is 0. So now the system becomes ready for you can say for executing the next instruction. Right. So we have executed a task. End signal is generated, after which the system is the counter is actually reset to 0. So as soon as we get an end signal, it is resetted. The sequence counter is resetted, and then we are ready for executing the next instruction. So yes, as soon as the execution is completed and signal generated, sequence counter reset, and lastly we are ready for execution of next instruction. Cool. So this was the working of hardwired control unit. Now let us talk about what are the advantages as well as the disadvantages of the hardwired control unit. So let me start with the advantages first. Mm, yes, advantages. As I mentioned earlier as well, since it uses no control memory and there is no need to fetch instruction from the control memory, therefore it is quite fast. So this is the first and foremost advantage of a hardwired control unit, that it is quite fast. Reason being, no control unit required. No control memory required. Please pardon. And since it uses fixed hardware circuit, right? The other advantages include that for a small instruction set is quite advantageous, since we are not constantly going and fetching the instruction or the data from the control memory. It's quite useful for if we have some small instruction sets, so beneficial for small instruction sets. And there is something called RISC, which means reduced instruction set computer system. The hardware control unit is basically used in such type of systems. So hardwired control unit are generally used in such type of systems. Now since we have completed the advantages, let us move to the disadvantages of the hardwired control unit. So the first disadvantage of a hardwired control unit, now we all know that it is very fast, but the thing is that it is quite difficult to modify. Now why does this happen? Difficult to modify. Now this is because that the instruction set as well as the control logic, both of them are tied together. Instruction set and control logic are tied together. So any change which we want to perform, because of this reason, if we want to perform any change, we will be requiring for hardware modification, as we have already earlier mentioned that it is using fixed hardware circuit. So if we want to modify it, then we would be requiring to change that hardware. It means that hardware modification is required. So physical hardware modification required. And now for this very reason, it is quite expensive to be updated. As we have mentioned earlier that it would be required to be updated, the hardware would be required to be updated, so we would just be required to either redesign it or replace the chips completely, which makes it quite expensive to update, and therefore this is very less flexible. Therefore it is used for small instruction sets as well, since using them on large instruction sets is not very feasible, as it is not very flexible in changing, and we would be required for doing the modification through directly, we can say, updating the physical hardware by either replacing it or by redesigning it. Therefore, let me just write it as a note. Therefore, it is rarely used in modern complex systems. Yes. So let us now start the second part of the video, which is about the micro programmed control unit. So we have already studied about the hardwired control unit. Now let us get to know about this second method. Now first of all, what is the basic difference is that earlier we didn't store or we weren't fetching the instruction in the from the control memory, but this time the control signals will be stored within the control memory. So whatever signals will be generated, control signals will be stored in control memory. Now we, as the name suggests, a micro program, what we will be doing is that small programs which will be called micro programs, they will be stored, and it is like we are writing small programs within the CPU to control the hardware. So small programs which are called micro programs are stored, and from this thing only the name of the control unit, which is microprogrammed control unit, is derived. So we are using programming approach. So whatever instructions will be executed, they are as a sequence of micro, they will be divided within the sequence of micro instructions. So each instruction executed is in the form of a sequence, is in the form of sequence of micro instructions. Micro instructions. So let us now see the block diagram of the microprogram control unit. So let me pause the video by the time I make that block diagram. Yes. So we have our block diagram for the microprogrammed control unit. So, starting from the start, this is our microprogram sequencer. What it would be doing is that it would be generating the address basically and sequencing all of these micro instructions we will be having within the process. Then we have something called control address register CAR, which is used to store the address of the next micro instruction. Then we have a control memory. The control memory is that important part which will be storing our microprograms, and it stores the control words in the binary form, in the form of zeros and ones. After that, we have a control data register CDR, which will be holding the current micro instruction, and the instructions will be executed, and then after that we would be moving to the next address information, and as soon as we completely execute it, it will be sent to the system bus. Again, here we have external inputs as well as the clock for naming calculations. Now let me just write down all these important components as well as their functions here. So starting from the start, first of all, list down the components. We have this something called microprogram sequencer, as the name suggests, sequencer. So yes, as the name suggests, a task of it is to sequence. So it would be controlling the execution sequence and would be generating the next address. Generate the next address. Next, we have something called control address register. Control address register. Control address register is basically used to store the next micro store the address of the next micro instruction which will be executed. So this holds or stores the address of next micro instruction. From here, as we have seen in the block diagram, we would go to the control memory, and this is the most important part of the microprogram control unit, as whatever we see the whatever microprograms we have are stored here in our control memory. So in a control memory, we are storing microprograms, and these microprograms are stored in the form of zeros and ones. Next in the list, we have control data register, which is basically used to hold the current micro instruction which is going on. Hold current micro instruction. So these were the major components. Now let us write down the working of this microprogram control unit, whatever we have seen in the block diagram, step by step. So working, first of all, what happens is that the information, whatever information is there, will be fetched within the instruction register. Instruction will be fetched. Instruction, as it is instruction register, instruction will be fetched by the IR, instruction register. So instruction would be fetched by the instruction register. Next, the microprogram sequencer, the sequencer will generate the address of the micro instruction. So microprogram sequencer will generate the address, generate the address of micro instruction. And now that address, whatever address is generated, would be stored within the control address register. As I have written earlier as well, that it will be holding the address of the next micro instruction. So whatever micro instruction is going to be executed, it would be held within the control address register. So address stored in control address register. Next, control memory is read. This is the place where our micro programs are stored. So it is read, and after that, whatever micro instruction we have gets loaded within the control data register. So now here we have our micro program has been read, and now we move to the next step where we load that micro instruction within the control data register. So micro instruction which was read in the previous step is now stored, or is actually loaded in the control data register CDR. Next is that now this micro instruction, as it gets executed, will generate some control signal. So control signal is generated, and then accordingly, as we've seen in within the previous part of the video, that the control signals generated are gone to the ALU register. Here, since the instruction was divided into various micro instructions, so uh, till all these micro instructions aren't executed, we follow the same sequence continuously, and then the whatever control signals finally are generated are given to the ALUs, or to register, to memory, or to the input output devices, right? So yes, since the control signals are generated, we will be repeating the steps, right? So in this process, our next address would be generated, right? And until the instruction is completely executed or is completed, we would be repeating this task, right? So process would be repeating, until instruction is completed. Cool. So this was the working of our microprogram control unit. So now let us discuss what are the advantages of microprogram control unit, and also the disadvantages. Right, so first of all, starting from the advantages, first and foremost being that uh, first of all, in the previous example we found that the previous example, which was right here, it had the disadvantage that it wasn't flexible. Now here, first thing which we are getting is that a microprogrammed control unit is flexible, so the instruction sets can be modified easily. And the reason is that we have been executing the microprograms within the memory unit, right? So instruction sets can be modified easily. Similarly, it is quite easy to design. Now why? Because what we are doing is basically we are using the concepts of programming, right? So we can say it's implementing those uh, means we are trying to implement these programming concepts, sort of like this software routines we are trying to implement. Therefore, it is quite easy to design, and in the for the similar reason, it is quite easy to update. Why? Now, in the previous example, what we were doing is that we were trying to update the hardware. Why? Because no memory unit was used, therefore we were required to update the hardware. But now here we can simply modify the control unit instead of the hardware, right? So we can modify that control memory instead of hardware, and this is why it is quite easy to update. Next, now in the previous example we were not able to uh, compute the complex instructions. We were using it for simple small set of instructions, but now this microprogrammed control unit, it supports complex instructions, right? So it supports complex instructions, and we know the reason why, because we are using microprograms, uh, like we are executing micro instructions, step by step, step by step, step by step. And since it is quite easy to design, easy to update, and we are using control memory, therefore it can be used for executing complex instructions as well. So this is used in something called complex instruction set computer systems. Right, let me write it down. Complex instruction set computer systems, or the CISC systems. So, of course, it might be having some disadvantages. The disadvantages include, first of all, in the hardwired control unit, what was the major advantage? Since we were not using the control memory, it was making it very faster. But now here we are using the control memory, and therefore it is going to result in some of the lacking within the speed, and therefore it is slower than the hardwired control unit. So it is slower than hardwired control unit. Now a reason is that since we are using this control memory, right, so it requires this control memory access. Control memory access. Memory access. Cool. Other disadvantages may include that again this is also expensive, since again we are using control memory, and some extra circuits are required for implementing whatever those software routines might be, like we are using those micro programs. So again this is also expensive, more expensive. Now even the previous example was expensive, but it was expensive when we were trying to update it, right? But this comes inbuilt expensive, because it is again using uh, various components, like yes, again the control memory and whatever required for those software routines, like extra circuits. So this are the advantages as well as the disadvantages of the microprogrammed control unit. So here we have, in this video we have studied about control units and two parts: hardwired control unit and microprogrammed control unit. We have seen the working by the block diagrams, and also seen the advantages and the disadvantages. So let me just summarize whatever we have studied as of now. We have this HCU, hardwired control unit. What we were doing, that uh, we were using fixed combinational logic having no control memory, therefore it was faster but not easily modifiable, right? So hard to modify actually, used for RIC, right? Cool. And then we have this microprogrammed control unit. Microprogrammed control unit. Now this we have control memory, uses a control memory. The control memory is used to store micro programs or micro instructions. stores micro instructions. Therefore, it is quite slower. Now, slower in the comparison of hardwired control units, so slightly slower. Easily modifiable than the hardware control unit, so easy to modify, which means that it is flexible, right? Next, we use it in something called CISC, where C stands for complex instruction set computer systems, right? So this was all in today's video. We have two more videos coming for the next part of the assignment. This was me, Shan Kumar Singh, B.Tech second year, Computer Science and Engineering, roll number 2024021065, section A. Thank you very much. Jai Hind.